Okay, so I know the first one probably jogged your memory a little bit. It's been a while since we looked at transformations. It wants to know what congruence transformation maps this onto DEF. So from this shape here, you could reflect it over the y-axis, so that would put it right here. And then you could move it up 3 units. So the answer would be, and it says describe, so reflect triangle ABC over the y-axis, and then translate 3 units up, like that. The next one, it says find the radius of circle Q. I know some of you probably would have skipped this one because it is a little bit longer. So the radius, the best way to do this here is to draw a segment right here. And then we're finding the hypotenuse of this right triangle. So it says this segment 16, half of that would be 8, so the dimension here is 8. And then to find this dimension here, we actually have to set this equal to this to solve for x first. So 2x plus 2 equals 4x minus 2. Assuming that you can solve that equation, it comes out to x equals 2. And then from there, you plug in the x to find the length of that segment. So let's see, 2 times 2 plus 2. This solves to 6. So the segment right here is 6 units. And then to find the hypotenuse of this right triangle, 6 squared plus 8 squared equals c squared. 36 plus 64. 100 equals c squared, square root of both sides, and it is c equals 10. So the radius of circle Q is 10 units. Next. Okay, now we have a circle. It looks like it has angles coming from the center, so central angles. Identify the given arcs as major, minor, or semicircle, then find the measure of the arc. So first one, it says BC. Always go the shortest route around. So BC right here would be 120, and it's a minor arc. Right? So it would be 120, and it's a minor arc. Using another color, it says AC right here. So AC right here, 60 degrees. And again, minor arc. If it's less than 180, it's a minor arc. Then it says AB, so you could either go around this way or the other way. It doesn't matter. From A to B right here is half the circle, so that would be 180. Then it would be semicircle. And then ABC, just connect the dots for ABC. Let's see, so it would be all the way around here, ABC. So it's all three. Are you guys okay? Okay. Okay. ABC is all the way around except for this part. There's different ways you could do this. You could do 180 plus 120, or you could do 360 minus 60. And that will give you 300 degrees, which is ABC. And that would be a major arc because it's more than 180. Okay, next one. Tell whether AB is tangent to circle C. If AB is tangent, then this would be a 90-degree angle, and this would be a right triangle. So we can use Pythagorean theorem to see if it is a right triangle. So if this equals this, then it's a right triangle, and then AB is tangent. So we get 100 plus 576 equals 676. Yes, that equals that. So yes, AB is tangent. Okay. Next. These are a little review of what we've been working on the last couple days. It shows measure JKL. It wants to know this angle measure right here. Well, this is an inscribed angle, and this is half of that arc measure. So 120 divided by 2 is 60, and so it's 60 degrees. And 41. Remember, it looks like 2 triangles, but you have to look at it as 2 angles. We got an angle there and an angle here. They have the same intercepted arc. This would be their same intercepted arc. That means that this angle matches this one, so this is 26 degrees as well. So measure angle PQS is 26 degrees. Okay, and last but not least, 43 was assigned, throwback to the beginning of the year. With the parallel lines, these two angles are supplementary, so you do 180 minus 137 equals 43. So angle 1 is 43 degrees. And then angle 2, alternate interior, are equal, so this would be 43 degrees. And then here you have consecutive interior angles, they would be supplementary, so angle 3 would be 137 degrees. And that's that.